15.4 Factoring Special Products. All right, so this is a special lesson because this deals with shortcuts when it comes to our quadratic equations, okay? So this is for a student who understands things like perfect squares and can see these numbers. You do not have to use this section in regards to making sure that you can factor a quadratic. This is just helpful if you want to do things a little bit faster, okay? Essential question of the day. How can you use special? I want to highlight that special because these are special products, things that you can times together to aid in factoring, okay? So this is all about speed. You can keep using what we learned in 5.3, just regular factoring, grouping, things like that, and it will always work. But this helps you with the speed of factoring, okay? So by recognizing, so you need to be able to see it. If you can't see it, keep moving. That a polynomial is a what? Perfect square, trinomial, or a difference of squares. Important to know what difference of squares is. You can use the appropriate special product rule to factor the polynomial, okay? Vocab. So vocab of the day, product. What does product mean? Means to multiply or just times something, right? And I always go into this because I want to make sure that you understand that 3 times 4 is the same thing as 3 times 4, which is the same thing as 3 times 4, which is the same thing as 3 times 4, which is the same thing as 3 times 4. All of these are just different ways of writing multiplication. So you have to understand that. Same thing goes with variables. If I just write a constant and a variable, there's no signs in between it, but it says multiplication. So I can easily times that. I can make it into a binomial and then multiply it by another binomial. So these are all multiplication deals, okay? The same thing goes with distributing. If I have 4 parentheses 6 plus y, this isn't saying anything, but it says multiply. That's why we draw arrows for distributing. Distributing is nothing more than multiplying. Same thing if I have FOIL, so 6x plus y, and I have 5x minus 6y. When I FOIL, I am what? I am multiplying 6x times each term in the second one, and I'm multiplying y times each term in the second polynomial, okay? So all of this is multiplication. I want to make sure that you understand that. Now, perfect square. Perfect square, let's really delve in. This is what you need to be able to see. So if I take the numbers, just simple, 1, 2, 3, 4, and 5. Let's go 6, 7, 8, 9, and 10, okay? If I add a square to them, just like that, something very simple, you will notice that you will get a number that we will call perfect. A perfect what? Square. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, okay? So those are all numbers that you should know. Why? Because if I take the square root of each one of these numbers, you will notice that I will get a whole number, and that whole number, you guessed it, is the number we started with. So the square root of 1 is 1. The square root of 4 is what? 2. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. And square root of 100 is 10. But it's not just as simple as saying the whole number there, because it could be what? plus or minus either one of these numbers. Now, if you're not sure why I'm writing plus or minus, you might need to go back and look at some of the lessons that deal with square roots. But every time you have a square root, you actually have two options, a plus or a minus. 6 times 6 is equal to 36. Negative 6 times negative 6 is also 36, a positive 36. So that's how we get it, and it works for all of them. A positive 6 times 6 is the same number, so that's 6 squared. So 6 squared is equal to 36. Negative 6 squared is also equal to 36. And you're going to have to later on be able to decide which one are you going to use, the positive version or the negative version. Our graphic organizer. Okay, so this graphic organizer comes from the book, okay? And I'm going to change a few things up because I don't believe in confusion. I know that mathematicians have done this, they thought about it and everything else, but I'm now talking to the student who has issues with all of these variables. Why is A standing for this? It also stands for this. So I'm going to change up some of our variables since we have a plethora of letters in our alphabet. Okay, but let's first talk about what are they doing. So we're going to factor our quadratic, that is a trinomial, by noticing something. We have to notice the perfect square. Okay, now they only deal with what? The coefficients and the constants. So this is only dealing with the coefficients and the constants. So we want a way to be able to deal with these coefficients and constants in such a way that we can easily see the number that they're going to be when factored. Okay, so you have to understand that point. So they list it as a squared plus 2ab plus b squared. Now, notice there's no x's in here because they're only concentrating on, that's right, the coefficients and the constants. Is there a way to break those things down quickly and be able to get a factored version of our quadratic? Okay, so here's the thing that you need to notice, and you'll see what I do later on. So a squared plus 2ab plus b squared. The result is a factorization of the quadratic that says a plus b times a plus b, which is nothing more than a plus b squared. Okay, so this is your final answer. And if we just look over here at this example, we have x squared. That has nothing to do with a. A is right here. Does that make sense? All right, in this scenario, this is b. Okay, so 6 is made up of 2a and b. Okay, so a was 1, b is the perfect square. Remember, a is the square root of whatever that number is. So square root of 1 is 1. The square root of 9, the square root of 9 is 3. So 2 times 1 is 2 times 3. And as you can see, trying to deal with a and b when I've already taught you a, b, and c, I'm going to switch these things up. But I just want to go over this. Here we go. We have a negative, so we get a minus b times a minus b, and we get a minus b squared. Okay, so let's switch this up so it's not so confusing as we go through. So we're going to list r and put r squared plus 2r times s plus s squared. The same result is going to happen. You're going to be able to see what r and s are, and then you'll just put r. Now remember, we never forgot the first term was always x, but we're adding the r in there. So r times that x plus s, r times the x again plus s, which really just means what? That's right, rx plus s squared. So our final answer will be in that format. Okay, so how do we use it? Here we go. Let's use x squared. I always put a plus there, plus there. Let's use 64. So this would be 16x. Okay? So now, this is what we've always done. We said this is A, this is B, this is C. We have no issues with that. So A is equal to 1, B is equal to 16, C is equal to 64. No matter what, whenever you're factoring a quadratic, we'll list them A, B, and C, okay? But here is where we figure out what R is. R is equal to what? That's right, the square root of A. S is equal to what? The square root of C. And now we can easily distinguish between what we're doing. We're only worried about the coefficient and the constant, A and C, okay? So what is the square root of 1? Because A is equal to 1. Square root of 1 is what? 1. Remember, plus or minus 1. So R is going to be equal to either a plus 1 or a minus 1. Then S, square root of 64. What is the square root of 64? Plus or minus what? 8. Now, all we have to do for B is say 2 times what? A R and a S. Now, 16 is positive, so we're going to use both a positive 1 and a positive 8. Look at that. 2 times 1 is 2. 2 times 8 is what? 16. So we got 116 and 64 as we go through, and we're good to go. So how do we write it in this format? That's right. Let's just come over here. R is equal to what? A positive 1, so we put X. What is S? A positive 8, so we put 8. R is 1, X plus 8. What is our final equation? That's right. X plus 8 squared. And that's how simple that is. Now, I took the long way as far as explaining it, but it does help you when you see that what? C is a perfect square, A is a perfect square. You have to recognize that. If you can recognize that, then your life is really, really simple. Okay, so here is just the fast way of doing it. If I said x squared plus, let's pick 81, right? So I have 18x here. This is my quadratic. X squared plus 18x plus 81. A is equal to 1. B is equal to 18. C is equal to what? 81. So I know R is equal to the square root of 1, which is just plus or minus 1. I know C is equal to the square root, not C, S. S is equal to the square root of 81, which is nothing more than plus or minus 9. Since B is positive, I know that it's going to be what? 2 times a positive 1, 2 times a positive 9, that gets me my 18. So I know 1 and 9 work. So all I have to write is what? 1x plus 9. 1x plus 9 is equal to x plus 9 squared. So even with explaining it, that's very, very fast. Long way versus the shortcut. Now, I know I said that the other way was fast. Well, let's prove that. Let's give us something simple. Let's say x squared plus 100. So this is 20x, okay? So x squared plus 20x plus 100. The long way. Let's do it the long way, which there's nothing wrong with the long way if you always get the right answer, correct? So here we go. We always start off with A is equal to what? 1, B is equal to what? 20, C is equal to what? 100. Therefore, I'm able to do what? Absolute value of A times the absolute value of C. Okay? So that is 1 times 100. What's 1 times 100? 100. Very easy. Now we list all the factors. Always start with what? 1. So 1 times 100. 2 times what? 50. 3? Nope. 4? Yes. 4 quarters, right? So 4 times 25. 5. 5 times what? 20. The 6? No. 7? No. 8? No. 9? No. But what? 10. So I get 10 times 10. That's pretty simple. Okay? I have all my factors. Now I need to know which one is equal to B, which is at 20, right? So I put an equals for all my listed factors. Since C is positive and B is positive, I know that all my factors are what? Positive. So let's go. 1 plus 100, 101. 2 plus 50, 52. 4 and 25 is 29. 5 and 20 is 25. 10 and 10 is 20. So which one works to get me to B? That is correct. The 10 and the 10. So now, how do I write my quadratic in factor form? So I put x in the first. We always put x. Then we use the second term with those factors. So plus 10. X is in the first term, and then plus 10. What is that really equal to? X plus 10 squared. So that's if you did it the long way, correct? Do all the factoring, go through. It's very easy. You still get the right answer. It does take a little bit of time. But if I took, let's say, 5 seconds, and I just looked at A, and C. So A is equal to 1. C is equal to what? 100. Are they perfect squares? Immediately you would say what? Yes. Since they are perfect squares, that means that R is equal to what? Square root of 1. S is equal to what? Square root of 100. With that being said, I get a plus or minus 1. I get a plus or minus 10. 2 times a positive 1 and 2 times a positive 10 get me to what? 20. That's my B. So I'm done. I put R, which is, remember, Rx plus S, and I do that 2 times. So here we go. R is what? 1. X always goes in the first one. What's my S? 10, a positive 10. So I get X plus 10 again, and if I write that, I get X plus 10 squared. I don't have to figure out all these factors and everything else. I already know what it is. It's less work for me. So shortcut. Shortcut requires you to recognize that A and C are what? Perfect squares. They must be perfect squares. If they're not, this shortcut does not work. Okay, example number 2. Well, what if B was negative? Well, let's look at it. A is 1. C is equal to what? 49. Are they perfect squares? Yes. Since they are perfect squares, R is equal to the square root of 1. S is equal to what? The square root of 49. So that's a plus or minus 1. This is a plus or minus what? 7. So here we go. 2 times what? A positive 1. That works. And you usually want to keep the A positive, okay? But since this negative 14, since B is equal to a negative 14, am I going to choose a positive 7? No, because that'll give me a positive number. A positive times a positive, just a positive number. But what if I choose negative 7? 2 times 1 is 2. 2 times negative 7 is what? Negative 14. And now it works. So R, X plus S, what is that? That is equal to 1, X, and S is equal to what? Negative 7 this time. So minus 7. Write that twice. And what's your answer? X minus 7 squared. Shortcut still works when B is negative. Does that make sense? So that's why I said plus or minus, you need to be able to choose which one as you go through. For the most part, little caveat, you do want to keep A to be the positive one, let S be the negative one, and therefore your binomials will work out, okay? When A is greater than 1, oh boy. So let's change this up. Let's see. So again, we're still writing what A is. A is 36. B is a negative 12. Alert, alert, alert. I know one of these have got to be negative. All right. And C is equal to positive 1. So what's our question? Is A and C perfect squares? The answer is what? Yes. Therefore, you can use your shortcut. Shortcut says R is equal to what? Square root of 36. S is equal to what? Square root of 1. That is plus or minus 6 plus or minus 1. So here we go. 2 times, and I said keep A positive. Let's keep our life a little bit simple. So A is positive, so I'm going to keep the positive 6. But since B is negative, I know that C better be that negative 1. Does that make sense? So here we go. If that is true, I'm just going to write it in that form, Rx plus S, Rx plus S, which, when I copy it down, R is what? 6. So I get 6x. What is S? Negative 1. So I put negative 1. So I get 6x minus 1. That equals to what? 6x minus 1 squared. And that's my answer. A lot faster. This is where the shortcut really helps you out. If A is equal to 1 and the C is really not that big, you can find those factors. You can kind of do those factors in your head to add up to B and go for it. But when A becomes a big number and C is a big number, it's a lot easier to do the shortcut and be able to quickly get an answer that is in factor form if they're perfect squares. Example number 2, when A is greater than 1, this is the case in point. If I have 25x squared plus 60x plus 36, and I wanted to do it the long way, saying A is equal to 25, B is equal to 60, C is equal to 36, well, you would have to do what? Absolute value of A times absolute value of C. So that's 25 times 36, which is what? 900. And now I got to do the factors of what? That's a lot of factors, okay? And you might mess up in the middle of it and everything else. So what you should do is what? Is A a perfect square and is C a perfect square? Yes. If that is true, then we can go into our shortcut. R is equal to the square root of 25. S is equal to what? Square root of 36. If that goes, so R is plus or minus 5. S is what? Plus or minus 6. So that means 2 times, well, B is positive. So that means I just have to use the positive version. Okay? 2, 5, and 6. Does that work? 2 times 5 is 10. 10 times 6 is what? 60. Yes, works. So here we go. Put in Rx plus S, Rx plus S. Okay, so that's nothing more than R is what? 5. Put the X. What's S? 6. So I got 5x plus 6, which is really what? 5x plus 6 squared. And there's my answer. That's a whole lot faster than even getting here to 1 times 900, because I know you probably came over here, did 36, 25, and you start writing it out. And you're like, what in the world am I doing? And you eventually got to 900. I'm already to my answer because the shortcut helps me out. If I notice that C and A are what? Perfect squares. That is exactly right. Okay. So that's the shortcut. This only works if you can notice perfect squares as you go through. If not, factoring quadratics the other way will always work. Whether A is equal to 1 or A is bigger than 1. You're able to do that by grouping.